It's now time to begin technical session number 5. Best strategies to mitigate waterlogging in urban area. Now we invite Dr. B. Krishna Prapoorna, Associate Professor and Head of Department, Civil and Environment Engineering, IIT Tirupati, to give a presentation on this theme. Ladies and gentlemen, with a big round of applause, let's welcome Dr. B. Krishna Prapoorna.
Thank you very much, everyone, for waiting, and really appreciate the Member of Parliament to be. He's very resilient. He's been sitting with us since morning for every session. Thank you, and special thanks to Professor Srihari. He's been very instrumental in organizing such workshops since a long time. It's important that I acknowledge him because he was my professor 20 years ago, and I still adore him. Mr. Ramurthy, we were supposed to do this about 3 years ago, but well, okay. And nice meeting you, Dr. Bhavi, and honorable other ministers here as well. It's also probably now I need to wake you up because all of you have had lunch, so it's important that I wake you up. Let's make this more interactive. Okay, if you have any questions, I can stop in between and then answer some questions. Okay, that's number one. Number two is I would like to answer some of the questions posed by previous people who asked questions on how can we improve the texture and how can we reduce the accidents on the concrete roads. One of the things that we have seen in international practice is that we do the tining. Texture is one, I forgot his name, the one who spoke. Dr. Vishal. Is he here around or? Oh, you're here? Okay. So to answer that question, we need to be doing the tining. And one of the other things that probably he didn't mention, what I just want to add onto what he said, there is a very, very subtle difference between the thin white topping and the ultra thin white topping. It's not just about the thickness, it's also about the joints that we have and the bonding, of course, but the joints, plus you have this texturing that we have to do very often, especially at the joints which are long in span. For example, if you have a 3 meter, 4 meter concrete spans, that will require grinding at the joints because you can also start seeing spalling and others. But ultra thin white topping, it's a very, very innovative technology. It's only about 50 to 100 millimeter in thick. And one of the other things that I'll be sharing with you today is the paver blocks, which will also. And then the other question on the plastic. So we have been very fortunate to have worked with rubber because I've been in this industry for about 20 years now. Since my days at the US, Sweden, and here, we have designed more than about 5,000 kilometers of roadway. We have seen that a composite pavement. Let's not take sides whether it's concrete or asphalt. Okay, that's not how we answer these questions. It has to be for the purpose. Asphalt has its own advantage, okay? And let's say we have rubber modified asphalt or polymer modified. We've also worked on plastic rubber modified. So to answer the other question on how do we dispose of these wastes, so we have these construction demolition waste, we have the plastic waste that we have used the fibers, we have used the steel, then we've also gone into the reinforcement with some other fabrics. So there are umpteen number of solutions to these, but we have worked on plastic modified concrete, plastic modified rubberized concrete, plastic modified rubberized asphalt. Solutions are there, okay? So now coming back to what I thought I'll talk to you is one of the problems that is there across the world. I represent the Indian Institute of Technology, Tirupati, which is one of the latest technical institutes established by the Government of India way back in 2015. And we have actually come across with this IIT as one of the fastest growing IITs in the country today, out of the 23, okay? And we have also got the sustainability rating, Griha Award and other things, apart from also being a sustainable campus on the 540 plus acre campus here. Okay, one of the other things I want to tell you is we are hosting international conference on smart cities next year, which will be hosted at Tirupati, but I really invite the honorable ministers and the members of parliament to come over and collaborate with us because Mumbai also happens to be a smart city, right? Tirupati is a smart city, and so we should be doing this together as an event. It's an international event. I bid for this. Out of the 18 countries, only we were selected in 2019 in Korea. So I think we should take this forward with all the information technology, IoTs and other things. Okay, coming back to this, we have actually placed some test sections. And Shri Bongirwarji is here, who was on the panel. Okay, I don't know if some of you know him. He was former Chief Secretary of Government of Maharashtra. And we recently presented this proposal to the Ministry of Rural Development. That's the Low Volume Roads Committee. And we have actually been approved to come up with the specifications for IRC with this pervious concrete. So I invite some of you to come forward and tell me if you can give me some test sections that could be built and then come up with the specifications. This will be for the low volume roads, but obviously it could be taken forward to the urban streets. Okay, so we have done some sections in Kharagpur where I worked for 4 years as a faculty. Before I moved to IIT Tirupati, now I'm a faculty at IIT Tirupati for 5.5 years. Also head the department. And we have done some field monitoring sections, which I'll share with you some of the details. And we have also come up with the paver blocks. We call that, you see, Param Paver. That's a fully make in India. So it actually goes back to Make in India, Swachh Bharat, Swasth Bharat, Skill India that you see here, and then I can also see some of the sustainability partners here. So I think we have come up with our own technology in India, fully made in India. Okay, I'm not saying pervious concrete originated in India, but we have taken it so forward that possibly we are the only group in the world right now which is much more advanced than the other countries, including New Zealand, Australia, Canada, and so forth. So we've done a lot of modeling. We have come up with the solutions. We have come up with the paver blocks, which is a composite structure, which I'll show you in a few minutes. So I actually support what Dr. Vishal has been saying since the beginning. So this is my group, research cluster. It's probably top 5 in the world today. Okay, that's what we do. We have more than 10 students with us, PhD students. Plus, one of the other things I want to mention to you is we have a large project with Ministry of Road Transport and Highways worth 13 crore. That's the largest transportation research project given to any institute in the country in the last 70 years. Okay, so we are constructing an accelerated pavement testing facility that could be used by any roadway agency in the country and abroad. In fact, this will be first of its kind in the world because we are also testing the vehicular pavement interaction, which none of the other countries do in the other parts of the world. This is our lab. So we have more than 50,000 square feet of lab space. Could you imagine? This is more than an acre of pavement engineering lab space that we have got. You can see some videos running there, pervious concrete. We have the state-of-the-art lab. Please visit the website there that I've shown you. We do some work on sustainability, asset management, material development, rubberized asphalt, rubberized concrete, and so forth. Okay, now coming to pervious concrete, what it is a material very, very special for us because it has interconnected pore structure. That something is much different than what you see with porous materials. Okay, this has interconnected pores, macroporous structure, which is why it has those conduits that can percolate water through the medium. It has the property called tortuosity that we are still being exploring. One thing that we should acknowledge here is these were actually built for the low volume roads. When I say low volume roads, the strengths are very low. You see there, it's about 3 to 28 megapascal. But we have increased it by about 3 to 5 megapascal with the inclusions of rubber, fiber, and plastic, which makes it much more closer to a medium volume road. When I say medium volume road, that's the subarterials or the arterial roads. One step further, have we been successful in coming up with high volume road pervious concrete? Yes, that also we have, and I'll share that with you in a few minutes. Porosity is very high. That's why it becomes a low strength material. But still, water draining, special characteristic material. Okay? And you see there, permeability, if you translate these numbers, okay, 0.2 to about 5 centimeter per second that you're seeing on the screen, that translates to about 70,000 millimeter per hour. The highest rainfall area in the country, 4,500 millimeter per year. This is 70,000 millimeter per hour. That is the drainage capacity of this material, which still has the high characteristic strength that could be placed as drainage conduits, as a low volume road, as a median, as a parking lot, walkway, and so forth. Okay? And you're not seeing probably the seats are here, but you can see the applications everywhere that we can use now. Now we have gone further up and we can start using these on the high volume roads as well. You can see the ingredients very similar to a conventional concrete. Okay? You see the coarse aggregate, cement, water, and admixtures. We use admixtures to make it more workable because we do not have finer aggregates in these, which also means you're saving the resources. You're conserving natural resources by about 40%. Now, if you want to conserve further, start using recycled aggregate. Some of the questions that came up, construction, demolition waste, can we use it here? Of course, you should be able to use it here. There is absolutely no question that you cannot use it. Okay, because you're trying to reach the low volume to medium volume, I think you should be able to use this. Okay, we have, and one picture that you see here, the first one, parking lot, MCT, Municipal Corporation of Tirupati. That pavement section was constructed in 2018 when I moved from Kharagpur to Tirupati. Till date, not even a single aggregate has come out. It's a good quality control that you have to really adopt. It's important. Okay, I've seen some good pictures that you showed today, 15, 16 years. But coming back to the question, can an asphalt do the same job? Of course, yes, because we have seen some sections in some parts of the world where asphalt rubber can stay for about 40 years. Self-healing capacity is there. So we have placed a test section near Calcutta when I was at Kharagpur. That lasted for 3.5 years when the highway became a national highway from a state highway. So when we designed this, it was a state highway. So the traffic was very low. It was a 2-lane road. Then when it became 6-lane, we only saw fine cracks. But the advantage with asphalt rubber is it has a self-healing capacity. The rubber is resilient. Okay, so it comes back after it cracks. So the crack propagation takes place, but it comes back to its original position. Okay, now what are the advantages of pervious concrete? From the road user's perspective, good skid resistant to answer that question. You don't need to even provide texturing. The nature of the material makes it skid resistant. Okay. Then reduced water spraying. Of course, I'll show you some videos. Less noisy. This is something that you people might be wondering, okay, can we reduce the urban noise in the ambience? You should be able to do that because it is able to absorb. You don't need noise barriers. You don't waste money on it. You could be using these. Okay. And the environmental groundwater recharge. Now, some questions were there, okay, what happens if the groundwater table is really high? You actually don't build roads there. That is the actual solution. You don't have to build. But let's say you don't have any other solution. Create good drains. Drainage is one of the solutions, right? I go back to the, my former professor, Matt Witzak, who happens to be one of the world leading experts. He's no more. But he wrote a book way back in 1969 where they had three important words. For any pavement design engineer, these three words are important. Drainage, number one. Number two, drainage. Number three, drainage. That's what he says in the textbook. Okay, so that is something that we have to do. And then reduce flash flooding. This flash flooding is what we are all facing in major cities. Can we reduce this runoff? Can we use it elsewhere? So we have actually created conduits. I'll show you some pictures where you can engineer these pervious concrete blocks with drains below. Use those water for some other purpose. That could also be done. That's not difficult. Okay, and then reduce urban heat island. This is something that all of us are worried about. As environmental engineers, we are all environmental engineers. Okay, we might be civil engineers, we might be a politician, but we are all environmentalists for a reason that we want a green planet, right? And urban heat island is a very important phenomenon across the world, and this can solve major problems. How it can reduce the temperature. In fact, the section that you're seeing here was inaugurated by the then collector, district collector, Chittoor district collector. Now Tirupati is a district. He asked me, can I walk on this barefooted? I said yes, for a simple reason. It is an acupuncture. These are all open texture. You can walk on it. So that is why the low volume roads, where people in the villages, they don't wear slippers, they should be able to walk on this. So there is a reduction of about 10 degrees Celsius. We have found this. It's a fact. 10 degrees Celsius, which means 60 in the hot climate zones will become 50. You should be able to use this barefooted. Okay, but better urban land use. LC is not my area, but what I'm saying is you should be able to come up with an engineered solution. Better cities, smarter and sustainable cities. I still feel, because I sit on the Smart City Council in Tirupati, we always keep saying, we don't want smart cities, we want smart villages. It should start from there. Okay, each unit should become a smart village. Then only it conglomerates into a good city. Yeah, so now let's start with the case studies. Quickly, we'll run through. The first one that started in Kharagpur. So it was a mega project funded by the first term of Narendra Modi ji. Okay, so we had a 25 crore project coming from the Ministry of Human Resources. Now it's Ministry of Education. Okay, we had one of the 22 modules was our pervious concrete. So we developed this from scratch. Now, if you ask me why from scratch, see the question. Again, going back, can I use a material that was developed in the US in India? Possibly not, because we have a geographical difference, we have demographic difference, we have other problems, soil investigations, other things, right? So we said, no, we will develop it from scratch. So we started with 100 mixtures. Can you imagine? 100 mixtures for a PhD. Now, people were laughing at me. They said, why 100 mixtures? I said, no, you need to be establishing a product and you'll have to do such a high statistically confident. Because I'm an academician, we worry about the statistics and other things. We said, no, we'll have to do this, and we did 16 experiments. Compressive strength, all of you are familiar. Porosity, density, emissivity, albedo, name it, it was all there. Okay, thermophysical properties, structural properties, hydrological, and noise characteristics. So we actually went across the spectrum. Okay, so first section that we got from the director IIT Kharagpur was 50-meter long section that you see. Yeah, so that was a 150 millimeter. This is after we developed our product. 150 millimeter thick section over a semi-permeable layer, which is a fine sand layer. So this is something that you want to adopt. Okay, so you have a semi-permeable layer. We will have a top layer with pervious concrete. Yeah, so you can see the construction procedure here. So we finished the soil preparation, and you see we also got the soil properties tested, Proctor density and other things that you're familiar. And we filled in the sand, which is a fine permeable layer. Okay, yeah, you can see now we are pouring the pervious concrete. They were all very small sections, about 2 meter by 3 meter, but we have now increased it to 5 meters also. We can do that also. Just showing you the process there. Okay, and then we do it in 3 different lifts. That is what we do, so that we get porosity throughout similar. That's exactly what we want to do. We also collected some field cores there, you see. Yeah. And then we use a plate vibrator. Now, one solution to this plate vibrator, or alternative I should say, is to have a screed. That is not very costly, very cheap. It's only about 1.5 lakh. And you can start paving about 6 to 7 meter at a stretch. Okay. One question that people ask me, how long do we have to cure this? 24 hours. Today you place, start using it next day. In fact, you can start using it within the 12-hour time frame. That also we have seen. And you see there, it's a thick section there, and then you start curing, like what Dr. Vishal was saying. Okay. This is the final section. Now it's being used as a parking lot and a walkway. And then this is on campus IIT Tirupati. Okay. Now we said, we will use the same, the best out of the lot, and then start placing it 4 meter wide and 125. It's a longer section now. What else we did here? You see, we also placed some pipes there in the bottom that could retrieve water and use it for some other purpose. Okay, this is what we did, similar to what IRC does, alternate slabs, and we could open this within 1 day. We got it inaugurated, and now it's still being used by JCBs. It has become a medium to high volume road now. You can see our cars there parked, all my faculty colleagues who came and saw this. Okay, now on campus, IIT Tirupati, what we did, we said, okay, people were asking me questions. Instead of actually having a compost pit or let's say a water harvesting pit, I said, don't worry, we can also have the pipes built within this section. So we had these CPVC pipes embedded within this section, okay, very strong ones. And you see there rings that we placed and thermocouples also for measurement of temperatures and other things. Yeah, so these were the rings that were placed below the pervious concrete. And then we poured pervious concrete. And you see those rings there in the bottom slide, bottom picture there. Those were the ones which were collecting water across the side drains. That could also be adopted. So we can engineer these. And we tested these for the infiltration, and we now have a new number that can actually support what ASTM says. American Society for Testing Materials says that 270 to 300 millimeter is what we need to have as the diameter to check for the infiltration capacity. And that's what we found. We are not very far, 270 millimeter. That's what. So we are able to even justify that with our materials in India. So now you see there, one of the other things that I want to mention here, we tried both in situ mixing and RMC. So can we start using this material with RMC? Absolutely yes. No problem, absolutely. Okay, you just have to tweak some place in between the transit where you add an admixture, okay, to make it more workable. Otherwise, it'll start to get clumps. So you see on the right side, that is in situ, not very uniform, but still doable. On the left, you see, that's the RMC, fully functional. Okay, now it's being used by the ambulance and other parking vehicles there. This is the IIT Tirupati campus. Okay, in 2020 December, we had deluge in Tirupati, which never happened in 60 years. Okay, it was a 70-hour rainfall that we had in Tirupati, which even my father, because he stayed all his life in Tirupati, he said, I never had seen this kind of a rain. But then what happened? This is the only location in the entire Tirupati which did not get inundated, along with the other pervious concrete site where we built on Municipal Corporation Tirupati campus. So very high permeability, still very durable. You can see the other. Okay, so we were able to do that with ready mix concrete as well. One thing I want to mention to you, there are some limitations of in situ versus the ready mix, but possible to iron out those also. I'll share these slides with you. You can look at those, but they're all not very high difficult jobs. But okay, let's move on. So 3 sections that we've already built. Okay, very intact, not even a single aggregate that has come out so far. Okay, and published documents in very reputed journals, ASTM, AAC, and others. Now we have also proposed this to the Ministry of Rural Development. So now it has been principally approved. So if the government of Maharashtra can come forward, we can get some test sections. This will be part of the ministry also. Okay. Now this is the last slide I have before we. So supporting the government of Maharashtra here. Concrete roads, good. They're very good, no doubt. Okay, use it for the purpose. We have now come up with the paver blocks. It's a composite paver block that could be used as a high volume road application. Instead of your panel concrete, we can use this where there is very high water table and water logging issue. You see, it's only a 30 centimeter block, square block. It's a composite structure with, you see here in the bottom there, it's a M30, M40, M50. You can design that yourself, a concrete section within which you have a groove wherein you place your pervious concrete. Okay? And that becomes a drainage layer for you. So it's a drainage layer upon the structurally sound layer. If you recall, I told you in the beginning, we want a composite structure that has a structurally sound layer plus a drainage layer, right? So this can help us. If you have a problem in waterlogging, a composite structure such as these will be useful. Porosity still maintained very high. Now the strength has increased. It has now become M40 together. It used to be M15, M20 pervious concrete. We have now increased it to M35, M40, M50, which can now be used as a high volume road. Right? The other thing, you see the flexural strength higher than what is prescribed by IRC, 6 megapascal, much higher than what you proposed, right, in the morning. So much higher, much sustainable, much durable. You can use rubber in this. You can use recycled concrete aggregates, construction demolition waste, plastic, and so forth. Please play this video. There are 2 holes in the bottom. It's a composite structure. Okay. Those 2 conduits can be connected to the other paver blocks. That way you can replenish water. Okay. You see that there. So, and this is about about 3 kilograms lighter than a paver block of similar dimensions with concrete, and 5 rupees cheaper per paver block. So if you go to the next slide, yeah, here you see total cost for one paver block is about 19 rupees. This is about 17. That's per kg, right? If you go there to the last column there, 48 versus 43. That's per square feet. 5 rupees cheaper. Now, if you can imagine per kilometer, and for hundreds of kilometers that you would like to use, I think you'll be saving much more, right? Other thing that we have done, this is what you see, 2 lakh rupees you're saving per kilometer, which is really commendable, right? Okay, now what do? Do we have to do much more? Of course, yes. We don't stop here. We are trying to increase the strength even by another 5 or 6 megapascal. That will help us in the long run. And the other question that keeps coming to me is clogging. Because this is porous, it'll get clogged because of debris, dust, sand, mud, and so forth. The solution is very simple. These are paver blocks. Remove, replace. That doesn't have to be done until the 3rd year. That also we have checked. Okay? So we don't have to really worry until the 3rd year when you have to do a maintenance. Every pavement section across the world is maintained every year or every 3 years. And these blocks could be just replaced. Take it out, wash it, keep it back. Okay? As I mentioned to you, now we are coming up with guidelines through National Rural Infrastructure Development Agency, but I urge you to also approach us. So thanks to several of my colleagues, my students, and others. Thank you very much for listening. I can take up some questions.
I have some questions for you. First is, what all examples it is inside the campus, right? So have you done it for any main roads?
We are doing it. We are doing it in the next 2 weeks.
So that is our main problem.
But that was the main road. The municipal corporation is a main road. It's being used.
No, it was in the campus. We have vehicles right from a bicycle,
Correct.
motorcycle, car up till the heavy vehicles. So the main problem lies with the multi-axle roads and how much pressure the road can sustain. So that is our main problem, and we want solution for that.
That can do the job because we are still using JCB on it. We are using JCB on this.
But the capacity of our roads, the volume of the traffic on that road, that is the main problem.
Sure.
So I think you should come up with an example, or you should do some experiments here.
Sure, of course.
We can support you.
Yeah.
And he is a MMRDA commissioner sitting here. So pilot project we should do somewhere where there is heavy traffic.
Absolutely.
Next thing you showed us with the pavers.
Correct. Paver blocks.
Yeah, paver blocks. The main problem with the pavers is not with the paver. It's with the soil beneath.
Correct. Agree.
The base. You showed us the water can be absorbed inside.
Correct.
So that is the best. But you require an infrastructure, a drain. So we require a solution. See how much difference between the traditionally what we do with the pavers. We put fine sand and then we put pavers up.
Correct.
But if you do this draining technique, so how much it will increase? What will be the difference between the normal and the new?
Sure.
It is the best that aggregates, any type of aggregates can be used to make the pavers. And what you suggested that if it gets clogged, you can remove it. I think it is not that feasible. Practically not that possible, with our pavers. So I think both the things on main roads, it is not the problem of the campus, it is the main problem of our main roads.
Agree.
And the stability of the structure beneath, what we can do with it. And main, as you suggested, drainage is the only solution.
Solution, of course.
So I think we should come up with we should do something on the main roads.
Sure.
If you can suggest, if you can, we can do a pilot project with both these technologies. MMRD commissioner is also there, so you can get connected to him.
Absolutely.
So we can come up with a new solution for our Mumbai roads. Otherwise, we are using this
Sure,
concrete
Very
continuously.
glad. Very glad. Sure. Definitely.
May I request Professor M.N. Srihari to hand over the memento to Dr. B. Krishna Prapoorna.
Today, he has overcome his guru. In Telugu, we call Guruvina Minchina Shishudu. There is a person who has overcome the guru also. But I was very, very happy, extremely happy. I request the God to give all encouragement so that he can grow further and become a model person for the country. So with this, I wanted to give a memento to Dr. Krishna Prapoorna.